Well, I was surprised, I have to say. To start with, I had not heard about Groningen and certainly not about earthquake engineering problems in Groningen. So for me, it was a surprise to be contacted about that. Then when I've informed myself a little bit better and I understood the problem of induced seismicity that was taking place, that was occurring in that region, I was still a little bit surprised, given that induced seismicity introduces levels of seismic excitation that are much lower than those introduced by tectonic earthquakes. And so I was surprised of the interest in carrying out an extensive experimental campaign for induced seismicity. It was big. It was very big. The testing campaign that we carried out here, which is part of an even wider testing campaign that has involved other research labs around Europe, is the largest that I've ever seen in the earthquake engineering field around the world. So if I just talk about the numbers here, we're talking about several tens of tests on the shake table and on what we call reaction walls, something that has never been done anywhere in the world to study the responsive structures subjected to earthquake loads. If I think about what was the most relevant conclusion, the most important result of the entire testing campaign here, I think was that we were underestimating the capacity of structures and the capacity of how components in masonry structures are interconnected and how that interconnection allows them to mobilize seismic resistance. We realized throughout this testing campaign that we tended to be very conservative, that is, underestimating the actual capacity of the structures. That was a lesson for us. We learned that our numerical models were very, very conservative. All our blind predictions always gave resistance inferior to the resistance that we observed on the test, in particular on the shake table tests. I believe so. However, I also believe that not as much as it could have been. In Groningen, you have in place this seismic code, so-called NPR, and in this code there's a number of prescriptions on how to assess structures subjected to seismic action, and those prescriptions use expressions and procedures that we have demonstrated through our experimental campaign to require improvement. They tend to be extremely conservative. That is, they tend to underestimate significantly the actual capacity of the structures in Groningen subjected to earthquakes, as we've demonstrated in the tests. And so we would have expected that the results of those tests, which are publicly available, which have been published, we would have expected them to be used to correct those expressions, those prescriptions in the seismic code, in the NPR, but they haven't. And that frustrates us a little bit because we see a significant number of structures in Groningen being deemed by the NPR or by whoever is using the NPR, being deemed as needing seismic retrofitting, seismic upgrading, when in reality they don't. It's just that the expressions that are being used have not been updated to reflect the results of our tests. Well, given that we've seen when we've compared the capacities of the structures tested in the lab to the capacity of the same structures as assessed by the current NPR, we've seen differences of 2, 3, 4 times the level of seismic resistance. So what would happen is that if you would upgrade the NPR, you would have a significant decrease on the number of structures, of houses that need to be seismically upgraded, because it would be estimated that their resistance is much higher than what is currently being estimated. The main result would be actually twofold. To start with, you would arrive at the conclusion that you would need to strengthen a number of houses that is considerably inferior to the one that has been estimated currently using the current NPR. And so a reduction in the number of houses that need to be strengthened. But together with that is that you would probably be able to focus much better your strengthening effort in the houses that really need strengthening, because your assessment of the seismic resistance would be much more accurate. So you would strengthen less houses and you strengthen the ones that really require strengthening. It was actually something that NAM insisted right from the start, that they wanted that this test campaign would serve the needs of what was being done and studied in Groningen, but also the needs of the research community, the earthquake engineering research community in general around the world. And this is the reason why when we were doing the tests, we were applying to the structures not just records, registrations, accelegrams from Groningen or from induced seismicity scenarios, but also we were introducing seismic input from tectonic earthquakes. This is actually a much more widespread building typology than one would have thought of, and than what I thought at the beginning. It's actually quite widespread. And now that you mention it, I can also say we've actually received requests for test data, for access to this test data, which we render publicly available as requested by NAM. We received just those requests from people outside of the Netherlands. So we received requests of that data from people in US, from people in Greece, from people in New Zealand. So they are interested in this test data, even if they're not really working on Groningen. As scientists, we're always very curious, and being able to explore new problems and satisfy our scientific curiosity, it's always a benefit, and that's one. As scientists as well, we need to publish. Our careers to progress, you need to produce papers, and we've been scientific papers in peer-reviewed journals, and also under the request of NAM, we've done quite a lot of that. We've, throughout these 6 years, we've managed to publish tens and tens of scientific papers in international peer-reviewed journals and in international conferences. So that's also quite a benefit. By the way, on this point of view, I might say as well that other scientists outside of Pavia that are making use of the results that have been produced here in this experimental campaign have also benefited and will continue to benefit. Third, our institution has also benefited tremendously, because before or at the start of this testing campaign, we had the capabilities of testing structures only in one direction. And now, thanks to this experimental program, this experimental campaign, we actually have improved, expanded our testing capabilities to test structures also under triaxial input motion, so both horizontal components and the vertical component. So yes, I have to say we have benefited quite significantly, yes. But if I might add, I think not just us, but the community in general, the scientific community in general has benefited, because as I was saying before, the results of these tests, of this experimental campaign, are being used and will be used more and more around the world by scientists that are studying the seismic risk of structures in all sorts of different areas. And they will also use that to develop new models, new softwares, and they will then also publish papers. And so it's actually benefiting the entire community. There's no doubt about that. This has been certainly the most exciting project we've been involved in our professional careers. I've been working in the field of earthquake engineering for 25 years. This has been, without a shadow of a doubt, the most exciting project, both in terms of the quantity of the work, but also of the quality of the work and of the new things that we've discovered. And so the fact that it's coming to an end, it's definitely something that we're not celebrating.